So now in this video, we're going to look at how do we factor when we have an a value. So an a value is when we have a coefficient in front of the x squared, or our leading coefficient. So zooming up on number 1, really this is the same as the one we did in the last video, and still with like grouping and factoring. The only difference is the first thing I have to do before I can look at my c value, okay, I have, like I said, an a value. So what I'm actually going to do is I'm going to multiply 7 and 4. Okay, well 7 times 4, that gives me 28. So now I'm going to say, what are factors of 28 that add to 29? And hopefully you're immediately saying, well, obviously that's 28 and it's 1. So now let's put that back in. So we're going to do 7x squared. I'm taking out the 29x and replacing it with 28x and 1x, and then putting in that plus 4. So again, I really haven't changed the problem other than how it looks. It still is the same thing if I were to combine like terms. So I'll go ahead and group the first two and the last two, and you should know what to do from here, right? Factor out a GCF. From the first group, it would be 7x, and that leaves me with x plus 4. And this is kind of odd, but the GCF from the second group is 1. So in this case, I do want to factor out a 1. I know it kind of doesn't make sense, but that's what helps me make my first binomial, and then my second binomial is that repeated one. So looking at number 2, same idea, 5 times negative 9, that's going to give me negative 45. So factors, of negative 45 that add up to 12. So something you want to keep in mind, since its product is negative and its sum is positive, one number is going to have to be negative and one will be positive. The bigger number will have to be positive for its outcome to be a positive 12. So factors of 45 are, let's see, we got 45 and 1, we've got 5 and 9, and then we've got 3 and 15. So immediately I'm going to cross out 45 and 1, that's way too high. 5 and 9, if I were to make the 5 negative, my sum would be 4, so that doesn't work. But 3 and 15, they do have a difference of 12, so that's a huge giveaway to me. So I'm going to make 3 negative so that their sum is not negative 12, positive 12. So we're going to take that, we're going to put that into my trinomial here. So I get 5x squared. Now you can either do the 15 with the 5, or you could do the negative 3. So I'm actually going to pair the 15 with the 5, because I'm thinking ahead, and I know that I'll be grouping, right? I'll be grouping the first two and the last two, and I just think 3 obviously pairs really well with 9, and 15 pairs well with 5. But again, you could flip that around, you still get the same answer. So my GCF of the first group would be 5x, leaving me with x plus 3. Notice how this guy here is negative, so I need to factor out a negative 3, and that leaves me with x plus 3. Awesome, I know I've done it right because those are the same. And my final answer is 5x minus 3 and x plus 3. Number 3, so I'll have to do 3 times 18. That's going to give me, let's see, I'm doing this in my head, 54. So let's see, factors of 54 that add up to 15. So I know that would be 2 and, let's see, 27. Okay, that doesn't work. What about 6 and 9, right? So that would be perfect because the product is positive, their sum is positive, so these will stay positive. So let's do 3x squared. We could do it with plus 6x plus 9x plus 18. Group and factor. GCF from the first group is 3x, leaving me with x plus 2, and the GCF of the second is 9, leaving me again with x plus 2, so I know I've done it correctly. And so here, my answer would be 3x plus 9 and x plus 2. All right. But you know what? I noticed something kind of interesting here. So I want you guys to start this. So whenever we're factoring, we always want to make sure we factored completely. And that means that when I look at my final answer, there's nothing else that I could divide out of it. And you know what's kind of giving me a red flag is this binomial right here. Because I noticed that I can factor out a 3. So my actual final answers, I want to keep factoring this. I want to factor out a GCF of 3 from that. So my answer would actually be 3, and then in parentheses, x plus 3 times x plus 2. This is my final answer. Okay, that is fully factored. Final answer. Okay, and now that I've noticed that, I kind of want to go back and make sure. Oh, I didn't close that parenthesis, sorry. I want to make sure that all my answers, see how I can't factor anything out of this or that, so I know it's fully factored. So it kind of brings up a good point. To me, this is a red flag that I could have factored out a GCF from here right off the bat. Okay, so I could have taken out a 3 from each number, so I could have factored out that 3 in the beginning. Okay, so let me actually just show you that really quick. Let me get my eraser out here. I know you're probably like, oh, this is a long video, but this is important to know. Okay, so anytime we have an A value, we also want to make sure that there's nothing else we can factor right off the bat. So A value, make sure there's not a GCF right off the bat. That would be 3. And so that gives me x squared plus 5x plus 6. Okay, and then I would go ahead and I expand that. Factors of 6 that add to 5 would be 3 and 2, right? So x plus 3x plus 2x plus 6. And then I would group and I would factor out a GCF. So the GCF of my first group is x, leaving me with x plus 3. Factor out a 2 from the second group, leaving me with x plus 3. And so I would get x plus 2, x plus 3, and I was getting a little too ahead of myself there. X plus 3, and then I don't want to forget about the 3 I originally took out, and so again I get that same answer. But both options work, but I prefer if you guys factor out a GCF as your number one step, okay? Because a lot of times we won't catch that we can keep factoring. So looking at number 4, now that I've personally learned that, I'm going to make sure that there isn't a GCF right off the bat, and there's not. 5, 13, and 6, they don't have anything in common. So I can go ahead and just go 5 times 6, and I know that's 30. Factors of 30 that add up to 13 are 3 and 10. And so I'll do 5x squared. And now I'm going to pair the 10 with the x, and then the 3 with the 6. I think that just makes the most sense, right? Group and factor. So GCF from the first group is 5x, leaving me with x plus 2. GCF from the second is 3, leaving me again with x plus 2. So I know I've done it right. Final answer is 5x plus 3 and x plus 2. Number 5. Okay, here's a good one. Okay, so I'm getting excited. So 6, 22, and 8. I know those are all even numbers. So red flag to me is, hey, I can factor out a GCF. Ding, 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 ding. GCF. OMG, that's my first step. Okay, so my GCF here would be 2. And so that leaves me with 3x squared plus 11x minus 4. So kind of the beauty of factoring out a GCF right off the bat is you don't have to do 6 times 8 and then work with 48, right? So now I can just do 3 times negative 4. I know that's negative 12. Factors of negative 12 that add up to negative 11 would be positive 12 and negative 1. So I'm going to expand my trinomial here. So 3x squared plus 12x minus 1x minus 4. Group and factor out the GCF. So the GCF of the first group is 3x, leaving me with x plus 4. GCF of the second group is negative 1, because I got to flip that negative here. So again, that leaves me with x plus 4. So I know I've done it right, because those are the same. So my first binomial is that 3x minus 1, and then the x plus 4. But I don't want to forget about this 2 that I originally took out, so that 2 has to be included. So my final answer is this right here. Okay? And remember, a friendly reminder that, again, your final answer, if I multiply it all through, should give me what I started with. So then looking at number 6, first I look for a GCF. So I've got 3, well, here's a red flag, 17 is prime. So unless 17 can go into all of this, then I don't have a GCF, and I don't. So I'm going to have to do 3 times 20, so that gives me 60. All right, this could take me a while. So let's think of factors of 60 that add up to negative 17. So, well, here's something I note is that those two numbers are gonna have to be negative because their product is positive, but their sum is negative. So let's do this. Let's do, okay, negative 2, obviously, and negative 30. All right, that doesn't get me close to 17. 3 and 20. All right, so that's, I'm going to add that. It's going to give me 23. Too bad I couldn't make one of them positive. Let's see what else. We can do 10 and 6. That's not going to work. let's see, does 4, ooh, what about 4? And I'm doing all this in my head, so bear with me. Oh, negative 15. No, that doesn't work. Darn. What about negative 5? And, negative 12. Okay, so you see, it took me a while to get here. And guys, honestly, this is my first time doing this problem. So you're seeing me naturally problem solve this out. So negative 5 and negative 12 are going to be my factors I want to replace. So 3x squared. Now, I know 3 is going to go really well with that negative 12. So I'm going to write negative 12 first, then the 5, and then plus 20. Go ahead and group and factor. So the first group, the GCF would be 3x, leaving me with x minus 4. All right, hello, this term's negative, so I got to take out a negative 5, so that leaves me with x minus 4 again. I know I've done it right because those are the same. And then my final answer is 3x minus 5 and x minus 4. All right, number 7. So I'm going to do 2 times negative 1, so that's negative 2. So what's nice about this is that there's limited options here to get a negative 1 sum. So that would be negative 2 and 1. So I'll do 2n squared minus 2n plus 1n minus 1. Group and factor, so I could take out a 2n, leaving me with n minus 1. Take out a positive 1 here, that's n minus 1. So my final answer is 2n plus 1 and n minus 1. And then finally from the section number 8. All right, so A is pretty big, so I'm going to make sure I can't factor out GCF here, and I can. I could factor out a 5 right off the bat, so that leaves me with 2y squared minus 7y plus 6. That really makes my life a little easier. So now I'll do 2 times negative 6, get negative 12. All right, so factors of negative 12 that are going to add to negative 7. Hopefully you're not saying negative 3 and negative 4. That was my first initial thought, because obviously it adds to negative 7. However, wait, you guys, I made a silly mistake. I was going to say, I said that 10 times, or I'm sorry, let's reverse here. I said 2 times negative 6, but 6 shouldn't be negative. It should be positive. I apologize. So this should actually be positive 12. So this actually would work. Okay, I apologize. So I'll replace the negative 7y. I'll do the 4 first because that pairs well with the 2, and then the 3 plus 6. We'll go ahead and group and factor. So my GCF from the first group would be 2y, leaving me with y minus 2. GCF from the second would be negative 3, so that leaves me with y minus 2. And so I kind of ran out of room, so I'm going to actually write my final answer up here. So I would get 2y minus 3, right? And then the y minus 2, but I can't forget about my GCF that I originally took out, so I'm going to make sure I include that. So there's my final answer. Now, sometimes, those last two problems, sometimes polynomials are prime or they're not factorable. So I honestly don't know if 9 and 10 are factorable in that, so we're gonna figure this out together. So looking at number 9, my first step would be obviously GCF, but we don't have one. I'll do 4 times 7, so that's 28. So now I'm going to look at, are there any consecutive numbers? And I'm thinking consecutive because it has to add to negative 1. So let's see, factors of 28. I know it's going to be 2 and 14. Obviously 1 and 28, but I know that's not going to work. But I'll write it. Let's see, 4 and 7. Not 3. That's it. And none of them are going to add to negative 1. Right? Because they would have to both be negative for its product to be positive. Yeah, so this one is prime. And so if I was asking you to factor that, you would just say it's prime. Or it's not factorable. And then number 10, let's see if this one is factorable. So still the same concept. I would do 2 times negative 5, so that's negative 10. All right, factors of negative 10 that could add up to 3. Ooh, this one is factorable because I could do 5 and then negative 2, right? So its product is negative, but its sum is 3. So this one would be factorable, so I would go ahead and put that back in. So 2x squared. I'm going to pair the negative 2 with that 2x squared because I know that'll factor well. Plus 5x minus 5. I don't know why there we go. So I'll group first 2 and last. Factor out 2x from that first group, leaving me with x minus 1. Factor out a 5 in the last, that leaves me with x minus 1. And so my final answer is 2x plus 5 and x minus 1.